Recording in progress.
No. Okay, mute it. You don't need to see me. And let's go, yeah. All right. So let's log in. All right, so as I said, the first thing that we're going to do is the TCP SYN flooding. I kind of demoed this on Thursday, but this time there's something in particular I want you to do in your homework, okay? So I'm not sure why it's saying. Okay. All right, so let's open up a terminal. And now the key thing here is, let me do something. Huh. Why don't I have internet? Was it, we had left it on bridge, right? Yeah. Yeah, it was, yeah, machine. Yep, we did this last week. All right, so hopefully that'll fix it. Okay, I think that should work. Yep. All right, so the only difference with this, we already looked at the SYN flooding attack, or yeah, the denial of service attack, but we didn't really look at it with the defense mechanism of the cookie, right? And what I want you to, and basically what I said on Thursday was, you know, to see that it's happening, you're gonna see when you do the netstat-na pipe grep TCP, you'll see a lot of half open connections, right? But you don't see the, you know, because you're doing the attack. Now, this time around, I want you to actually run a Telnet connection. So you have to create a Telnet connection while the attack is happening. But you have to do it both with the SYN cookies mechanism and without. Does that make sense, guys? So that's really what is part of the assignment. Okay, so let me just. So let's just kind of, I'm going to walk you through it. I'm not going to do it. You guys would do it, but I'm going to give you kind of the basic idea. Okay, so for this attack, you're going to do this. First, you're going to, you know, you take the SYN cookies mechanism and you disable it. Okay, so you're going to do sudo sysctl -w net dot IPv4 dot TCP SYN cookies equal 0. All right, so you're turning off the mechanism, okay? And so basically when the SYN flooding mechanism is there, it should allow you to connect much better, right, than without it. So we turned it off just now. Remember what SYN cookies does is it basically gets information about that TCP connection and it sends that information back as a hash value. If it sees that information back, it'll be able to compare the hash value and determine if it's a correct connection or not. Yes, go ahead. is called SYN cookies, the one I just described. So it's a mechanism we saw in 350, if you remember. So it basically uses hashing. Hashing is what? Cryptography, right? You know, MD5, you know, that kind of thing. And so it'll send back in the sequence number a hash value that it's, you know, only the machine can compute. So if it sees a packet coming back with that same value, it's going to validate and let you in. So this is the command for turning off SYN cookies mechanism, okay? Once you've turned off the SYN cookies mechanism, you're going to telnet into the machine. Remember, you should have 1 or 2 VMs here. So you telnet into your machine, whatever it is, 192.168.1.3, okay? But you're gonna try to establish now test it first, obviously. When you do that, when you do something like that, you're gonna see the connection as established. Okay, so you're gonna see the connection as established, right? And then login is CDs, right? So you should be established on the machine. We open another terminal and we do netstat -na pipe grep TCP. We should see, oh, and I'm gonna do this. Okay, we should see in here, establish connections. This one, right? Probably. We have our established connection for Telnet on port 23. Make sense? So you get the connection there. Now the question is, will you be able to connect to Telnet? I'm going to exit out of this one. See, for connection closed by connection has been closed. All right, so now we are back to the VM. And then here, okay, now one of them is missing. All right, one of them is missing as far as the connection is concerned. But this was fine because there's no attack going on. Although the TCP SYN cookies is off, there's basically no attack. Okay, so now the scenario that I want you to follow is that you're going to, once you've turned it off, you're going to run the attack. Now, in this scenario, the attack, as we discussed, will work better with Netwox. So not all attacks will work with scapy or Python, just because, like I said, they have to be somewhat fast and efficient. So in this particular case, we're going to do Netwox 76-I. This will be faster than Python for the computer, if that makes sense. So it'll be, more intensive. And I've tested this. This attack actually should work. So then here again, put your, whatever your IP is of your target. Remember, you're targeting port 23. Okay, so you're targeting the Telnet, right? Because that's the thing that you're going to connect to, right? And so, but you're also targeting with an attack, and you're trying to overwhelm this attack. I'm not going to run the denial of service. I've already demoed that last Thursday, but you can see this is how you can run the attack and target. Once you run this one, as you run this attack, you will basically be flooding the computer with all these, and then at the same time there, you will run the netstat with another terminal, and now you'll see a whole bunch of SYN receive connections, right? And that just means that the attack is no longer, that you're getting flooded, basically. While that's happening, leave the attack running, and then now try to telnet again. Okay, this is the scenario where if you telnet again, it should time out. You see that? So the objective of this experiment is that you are not able to Telnet because SYN cookies is off, and also you have a Telnet attack running. Is that clear for everyone? All right, that's it. So if you understand that, then that should be it. So I've given you all the commands, and then what do you have to do once you complete that? Now turn on SYN cookies again, turn it back on, and then do the exact scenario again. This time around, what will happen with your Telnet connection? In theory, it should connect, right? You guys understand? Because the SYN cookies will basically help you out with that. And then to just do that, to re-enable it back on, you just have to set it. Maybe it wasn't this one. You just have to set it to 1. Okay, so you'll just have to set the command. All right, and that's it for the denial of service attack on the experiment that I told you about. Right, so that's one problem. I'm still not sure how I'm going to do these. I'm thinking that will be one assignment, like one link on Brightspace. Okay, just because it's easier for me to grade things when they're like simple like that. So how to assign weights to, and it's a good nice exercise. Now let's take a look. So if there are no questions with TCP flooding, SYN flooding, and everybody understands the requirement for the homework, let's go ahead and move on now to TCP reset attack. Okay, so this one should be fun, I would think, for you guys. We're going to do TCP reset attacks on 3 things. We're going to attack Telnet, we're going to attack SSH, and we're going to attack YouTube. Obviously, some connection. You have to think about how you're going to do it within your own environment. Again, with all these things, whenever you're doing attacks, remember it's only for academic things, and you're only doing it in a controlled environment and not on campus. All right, so let's go ahead here. And I'm not seeing any questions in the chat, so I'm assuming everyone is following along. All right, so TCP, as I said, so we're gonna do, I'm gonna move, so let's switch over to the, as I said, to the whiteboard. So one of the key things that we will need, especially for something like YouTube, as you know, is that whenever you have TCP connections between, 2 entities, right? The packets carry information in the TCP header, right? Specific information that you might need in order for the computer to accept what you're doing, right? So the key of a lot of this is that we're gonna set a flag called the reset flag, right? So, as you know, with these packets, right, you'll have acknowledgement, right? And then you have reset, and then you have synchronization and things like that. And all of those are basically little flags in the packet, okay? So in our particular attack, these 3 attacks that we're gonna look at today, they're all gonna be reset attacks. However, we might need some information from the packets themselves. And if you remember, these packets have what is called a sequence number, and they have the acknowledgement number. And in this lab in particular, and then in the next one, the session hijacking, these numbers are really important. so I'll get into a little bit of it. But for now, it's not so shouldn't be so complex. So we'll take a look at this idea. All right, so as I said, we're going to do basically for the reset attack, for our reset attacks, we're going, and this is for your assignment, you need to do reset on Telnet. We'll start with that one. We'll start, then we're going to do SSH, right? And then you're going to do, well, let's call it multimedia. But in theory, you can you can do this on a lot of types of multimedia. In the past, students have just gone on YouTube. They actually usually just go to the channel of this class and just, I think, take out all their anger on that channel. So anyway, so you'll basically, whatever you want to do is fine. Okay, but I think this should be a fun assignment. So I'll walk you through. So I'll do kind of, again, I don't want to solve it for you per se, but I will walk you through the methodology. So how you would do it. Again, just like we've been doing in a lot of things, we're going to need a couple of tools, Wireshark, right? We're going to need Python and Scapy, and also the Netwox tool will be nice to have. Okay, so let's go ahead and move over to the virtual machine over here. Okay, so we have to think about what we need. So this is TCP reset attacks on Telnet. So let's start Wireshark. All right, so I'm gonna do any we had said. And in this particular case, we just want to filter because you can see there's already traffic there. All right, so we can basically here then just capture the Telnet packets. Okay, so now let's go ahead and connect. Right, should be running now. All right, so now let's go ahead and open a terminal here. And I'm gonna do, I only have one machine, but you guys can have two machines. I'm gonna run Telnet, let's say 127.127. What is the IP? Well, Telnet 127.0.0.1. Okay, and then if we go on Wireshark, you can see already that there's traffic going on here. You can take a look at it. It is a Telnet connection, as you can see. And if we click on it, of course, we can now start to see the different headers. In particular, here we've got the we have here the Telnet connection. Notice that there are some values in here, like the sequence number, right? That's already relevant to our purposes. Now, I should say these Telnet numbers may not look like this to you, like really long numbers. If they look very small, that you're like 1 and 2, I don't know what you have. It means that your setting in Wireshark is set to relative. And you need to change that setting to display the actual number, okay? Your numbers will not be, your sequence numbers will not be like 1, 5, right? They need to be those because by definition, sequence numbers should be random. And we'll talk a little bit about that next week as random numbers. This is important, right? If you know a packet and you know where the sequence is, and you know that sequence number, you in theory could hijack that connection. All right, and so that's kind of what we're playing with today. Okay, does that make sense, guys? Does this make sense? Okay, great. So so these are some, as I said, some of the fields. And now what's going to become important is we're going to start to look at some of these values, right? And just try to harvest them, if you will, manually and type them into our code. Okay, but at least you now understand. Now, if you're looking for where the connection is, just look at the last Telnet packet. the last telnet packet is basically the last thing in the connection. So that's where it's kind of waiting. And so that's why it's nice to start with telnet, because now if you want to kind of communicate there, just look at the last packet, grab the values from it, or where the sequence is in the exchange of data. Okay, so we talked about Wireshark and we've talked about telnet. We've talked about being able to look at the packet there. All right, so if you look at, as I said, if you look at the last packet and viewed its content, you can see the numbers in. The next thing that we want to do is now we want to do an attack, right? So we want to start thinking about doing an attack. So we're going to write a program of attacking the computer. Let's call it whatever we want, telnet reset, for instance, right? Something. And basically, we're going to try to think about the correct information that should be in there, right? To reset and be successful. As I said, I'm not going to solve it for you. So you still need to do a little bit of the experimental, investigative work to figure out what are the right fields, but I'll certainly give you the code that should work. Just keep in mind, we're going to plug in some data, maybe from the last packet in the telnet connection that you should be seeing there in your here. And then we're going to try to send out a spoof reset packet, in this case, to the computer. And you have to think about, because you have a telnet connection, so you have a client and server architecture. Remember, the port numbers are important here. Port 23 is going to be on the server side, right? And so you have to think about how you're going to target things. Okay. So now, let's go ahead and write the script. Okay. And this will be our first script. Oh yeah, all right. So let's call this one. So now leave Wireshark there. I'm gonna exit. I'm gonna ls and go to the desktop. And let's just use the folder. For spring. Okay. So now let's just create this script. I'm going to call it. So for this one, you don't really need to use Netwox for this attack, although I'll show this one should work. So let's do telnet reset.py. Okay. Oops. Telnet reset.py should be a pretty simple script. From scapy all. Scapy.all import all. Let's just put in a script or some here. We'll say sending reset packet. Right, so we're gonna send our reset packet. then we, of course, we're going to send it down here. So we send the packets, comma, set verbose to 0 or 1. You can play with that parameter. And we're going to craft a packet. And that's really where we have to look at some information. So I'm going to do packet. It's going to be a TCP packet, right? So IP layer. And then we're also going to do the TCP layer. You can also view your packet, just do ls packet. So now that was the easy part. Now the tricky part is, how do we do this? So let's look at the IP layer first. So in the IP layer, you have source and destination. So this will be dependent on whatever it is that your network is. Let's just say 192.168.1.16. Destination DST is going to be, the other. So 192.168.1.19. Okay, so that's your IP layer. Now, that's easy. Now we just have to think about the TCP layer. And actually, sorry, this should be IP layer equal IP. All right, so IP layer is just a variable. Now we're going to do the same thing, but for TCP. Let's see, there's a question. Could you move your mouse? The word terminal is blocking it. All right, so now the trick is, so now the TCP layer, we're going to build a TCP. So here, you guys tell me, what do you think you would need for this? What are some fields? So S port, right? That is the source port. So what is that going to be? You'll have to think about it, right? And then also here, you'll have the destination port. So you'll have to figure that one out. Where do you get that from? Because you're trying to, what are you trying to do this time? You're trying to break a specific Telnet connection, right? So then you're going to go, for it to reset, it's going to check several parameters, right? So which one do you want to reset, right? So it's going to go, so if we go back to Wireshark over here, and if you click on the last one, last packet, you can see there should be here source port and destination port. So it's got to be the specific ones for the connection you're trying to break. Okay, so get those. What are some additional things? If you want to use the, well, obviously the flags. So the flags here is going to be the R flag for reset, and then also the sequence parameter. And in this case, it's going to be the sequence number. So I'm just going, again, you'll have to play with this, but it's going to be obviously specific to your setup, but this one does not go in double quotes. It's just a number. And you can look over here in Wireshark. You can go over here in Wireshark and just grab the sequence number like that one. So let's say 32, 21, 50, 32, 21, 50. $18.98. remember, it's got to be the actual sequence. Does this make sense, guys? And that's it. That is Telnet. And it should be. Once you do this, you need to obviously have an established Telnet connection. When you do the reset, it'll break it, and you'll see that the connection has been broken. Got it? Pretty easy, right? So that's the first one. So are there any questions on this one? All right, so let's move on to the next one then. And you know, that's part of your exercises. So run the code, obviously, you'll need to have access to the network card. And then you should see that the connection has been closed. The next problem is going to be to do the same, but now with SSH, right? So we're going to do sort of the same thing. We're going to go to Wireshark over here. Let's kind of start fresh with Wireshark. This time around, we're going to say SSH. And let's have it sniff just on SSH so that we can limit the traffic. So now you're going to sniff SSH traffic. So now go onto the terminal and you're going to do SSH, some machine, your other machine that you have in your network. Okay, I'm SSH. And then you can see now I have my SSH traffic in here. Same idea, click on the last one, right? You can see all the headers in there. You can take a look at the TCP protocol. You can see that there's the source port, destination port, sequence numbers, you know, and all of that, right? And then you can look also at other aspects of SSH, etc. Okay, the encryption information. So this scenario is similar. This one should also work with your with scapy. So once you have the packet, right, and we've established a connection, you can look at the last packet, view its contents, so that we can get the value. Yes. Yeah. This one. Just SSH. It's just you're literally just SSHing. Try it with different computers at home. Try it with PuTTY. You know, why not try it with PuTTY? So you have your Windows machine, your Linux machine, PuTTY in. Play with this, right? As I said, it's up to you how you do it. All right. So as I was saying, we capture the data SSH. Okay. And you're going to make a connection. So you have the established connection as I have over here. Once you have that, then we're going to create a little script, which will be similar to the previous one. All right, so really, literally, this one is almost exactly the same, right? So I'm just going to copy it from the previous one. So I'm going to do. So I'm going to close that connection. Yeah, so I'm just going to copy this one. But I'm going to give this a new name. I'm just going to call it SSH reset.py. Okay, so now we're going to go ahead, create the script, create it. Now we can just go ahead and open it and just basically some minor modifications. All right, so here, the IPs are dependent on your scenario. We're still doing a reset. You're still going to get a sequence number. Remember, this is, once again, you have to go to the connection, kind of look at things, experiment with the different sequence numbers until you are successful, okay? But basically, think of what it's expecting there. And then the only thing is probably these are going to be dependent, right? So one of these is probably port 22 instead of port 23. Okay, there's a question. Yes. So in the chat, somebody asked if you can use the host machine as the other machine. Yes, use PuTTY or something if you have a Windows machine. Okay, great. All right, so any questions? SSH should be pretty straightforward as well. Very similar to the other one. And then obviously you need to break the connection, okay? So you will need to break the connection. Now, those were easy and they were kind of done manually. But the next one is a little bit harder. This is a harder one to do. So we're going to take a look at how we can do this in both ways, you know, with Python scapy, but also with the Netwox tool. So let's think of how we would do this attack. So this one, we're going to call it TCP reset on video streaming applications, right? So this might be like, you know, as I said, Netflix, YouTube, one of those. So let's close this script. Here, unfortunately, you will not be able to capture the packets manually because, as I said, by the time you grab one packet, the streaming has already gone, you know, millions of packets into the future, right? So that's not going to work. So if anything, we wouldn't be able to write the code like we wrote it before. We would have to have some kind of an automatic way of doing it, right? So that's the first thing we're going to think about. So we're going to make a program on the attacking computer that sends reset packets to the client, right? So don't send them to YouTube or to Netflix, right? Send it on your own environment, please. So you're going to send these reset packets to your client computer, which should disrupt the, let's say, the YouTube video that you're watching, right? But in essence, you know how sometimes the circle will appear on YouTube, or it'll say something like the connection is slow. You should see something like that by breaking that connection. All right, so let's create a new script for this one. Let's just call it, you know, disrupt. Well, let's just say reset video. Let's do that. So nano. I'll write this one from scratch, given that it's kind of a new one. So reset video.py. All right. So the idea here then, again, we're going to use scapy. So from scapy.all import all. Okay. So this is one of the sniff and spoof, right? So we will need to basically sniff the packets and then spoof something to try to be much quicker in our attack here. So I'm going to do packet, and it's going to call sniff. We need to specify a filter, so you'll have to think about that filter, right? So filter will be something like what? What are you trying to capture? Well, do it by IP, right? Probably the specific IP of your connection would be useful to filter out a lot of traffic. Also make sure it's TCP. So think of a filter here that would be appropriate. And then once we capture the packet, we need to have a function that's going to handle that. So let's do spoof underscore video, let's say. So now let's create our function here. Spoof video, okay? And this should take our packet as we have seen it. Okay, so that's the idea then. So now 1, 2, 3, 4. We're going to craft our packet Oops. We're going to craft our packet here. We're going to create the IP layer. It's going to be an IP. Okay. And again, we need to specify the destination IP address. So let's just leave that blank. We're going to do the destination and then the source of that packet. So I'll give you a general mechanism, right? So we've seen this mechanism before. So instead of hard coding the IPs, an alternative is to grab the IPs and of the current packet and flip them, right? If you remember. So I'll just give you that approach as well, and you guys can kind of think about it and play with it a little bit. So this would be the packet, and then remember, all we have to do is from the IP header, we're just going to grab the destination and assign it to source. You guys remember this part? So you can just do something like that as well. And you can do it for both, actually. So I'm just, showing you examples. Should be doable. Now for the, we're going to craft the spoof packet. Right, remember this is just going to be made up of IP layer, but we also need to specify a TCP layer. Okay, so that's probably the hardest part. So we'll need to specify that. Here we have the packet, and then we're just going to send it out. So that should be send, and then we have spoof. Spoof packet, and yeah, verbose or not. Right, 0. So now the only thing that we still need to figure out is, which actually this line of code is also pertinent to the next lab, which is TCP session hijacking. So that's also a fun one, right? Where you're going to try to hijack some connections. And actually, we're going to do things like what we had done in 450. If you remember, in 450, we stole some files, I think, and we did a reverse connection. So we'll do the sort of the same thing, but with this session hijacking. So we'll talk about that a little later. But I want to stress this is sort of the same mechanism. So it's actually pretty straightforward once you understand it. So you're just going to do TCP layer here. And then we just have to think about the flags that we need in this header. So we have the TCP, right? And the flags are, oops. Obviously, all of these attacks are reset, right? So the one thing they have in common is the R flag. Okay, you see that? So that's the R flag over here. And then now the things that we want to define again are the things that define that connection for the video streaming. What are the things that define that connection for the video streaming? Source port, destination port, and the sequence numbers. Does that make sense, guys? As we saw it in the packets themselves. So now we can go ahead and plug those in. So we're going to say D port. And let's just leave it kind of blank for now. And we're also going to specify the source port. And also the sequence number, right? But this time around, instead of getting them from Wireshark, that wouldn't be practical because it'll never work. Instead, we're going to try to get them from the packet itself. So we're just going to do PKT, and then what part of the header or what part of the packet are these coming from? Which header? TCP, right? So these are coming from the TCP part of the packet. So TCP. And in this particular case, since we're sending out a packet based on a packet we receive, we're going to flip them, right? So destination port, you would do source port. And then the same for source port now. We're going to define that as the source port is going to be PKT. I'm going to move this down also. Right, so source port from the packet, we're from the header TCP, okay, from TCP header. And now we're just going to grab the flipping of it. So D. Make sense? And then the last part of it is the sequence number, right? So now we want to get, the sequence number. So here there are several alternatives that you will have to consider, right? So you'll have to think about this. What's the sequence number, the ACK number, the next sequence number? You have to figure it out. You'll have to think about it a little, right? Or research it a little bit. I'll just provide a general framework of how you could get it. So it'll be something like, obviously, from packet, right? Packet, and then, well, that it's in the TCP header. But then now here, that's the question, right? So what is it going to be? So I'm just going to put here, what is it? Okay, that you have to use. I mean, hopefully that makes sense, right? So kind of figure it out, think about it, some options. I'll put some options here for what is it. So it's going to be, the sequence number itself, or the the acknowledgement of it, or something else, right? So you'll have to think about it a little bit. Does this make sense, guys? That's the logic. Basically, this one is different, as I said, because you have to do this approach. So try to run it and see if you can disrupt it. Remember that it's a little bit, it might be a little bit tricky here, right? So see if you can. If that gives you trouble, the other alternative that we have is to also use Netwox, right? So Netwox is a little bit faster. So you're going to do this experiment as indicated in the handout, and then also you can try the Netwox command. So in this case, to do reset attacks, so we have to think about how to do reset attacks with Netwox. Okay, so let's do. All right, so as I said, the next alternative is to use Netwox. So I think the command for that is. All right, so it should be for reset attacks, sudo. Should be sudo Netwox 78. Okay, but you need to specify some kind of a filter for this. Okay, so you can do. So you're going to do -- filter And then now you have to craft a filter that's appropriate. So what I would recommend here is run this Netwox command on the attacking computer, of course. See, in theory, you should have 3 computers, right? You should have the computer that establishes, but I'm not asking, for you guys to have to set up so much. However you can do it is fine. But really, if we really think about it, we have the, in all of these, we have the client, the server, and the attacker, right? So we have the client, the server. So in this case, if we're doing, this is like the multimedia server, right? So YouTube or whatever it is, right? And then this is the client, the browser, have a connection established, and then there's an attacker. Okay, so here, remember, this is out on the internet, so certainly do your attacks in that direction. Okay, so you will do your attack in that direction towards your client and try to break that connection from the attacker. So this is where you would run Netwox. And as I said, 78 -- filter. But now you have to think of, what is maybe the source or the destination IP. So you'll have to be able to get that information actually. And I'll leave it to you guys. All right, once you have that, it'll grab the packet and try to break the connection itself. Does this make sense, guys? So we had done a little bit of this before. So today I'll actually cover a little bit more of Netwox as a tool so that you have it available. Again, once you do this attack, in theory, if you had let's say a YouTube video, right, it kind of looks like that. The video is streaming, but then all of a sudden you get that little circle, right, that happens and the connection breaks. And that would be the evidence that you were successful in your attack. Whether you achieve this via Python or via Netwox, that's fine. Either one is fine. Do the experiment actually with both, okay? And make sure that you have a good sense of how it works. Are there any questions so far? Nope. All right. All right. So the next thing we're going to do is I've been talking about Netwox a little bit. So that's as you have seen, that's a nice tool that we use. I demoed last week. Okay. So today I'm just going to go over it a little bit more. So provide some of the commands that are available in it and some of the syntax of it. So let's go back to the virtual machine. Okay, so we are here. Okay, so the Netwox tool has several commands. So if you wanted to do our poisoning, which there is a lab for that, which we might do, but basically I'm just going to give you the command. So for that one, it would be Netwox 33, right? So if you want to take a look at it, get some more information on Netwox. I think it's --help. Yeah, so it'll give you information on how to do the configuration. So this is definitely a nice tool. This class is not about attacks, but certainly it's worth knowing, especially for this family of attacks, which are network spoofing type of attacks. Okay, remember, this is not Metasploit. We're not doing buffer overflows or anything like that. But for the particular family of attacks that we're looking at, which are basically sniff and spoof type of attacks in the network, taking advantage of the design of the protocols, this is certainly the tool. So you can look at it for anything that anything that you want. So in this case, yeah, you can do it for individual attacks there, right? And you can see here it provides different information on the things that we can do. So there's quite a few. There's also, if I remember correctly, there's a version of this that is GUI. And there you go. Yeah. So if you notice, I just opened it. This is also something nice and handy for your term project. Also remember, you will have to do some attacks. So if you want to think of some new and original ones, this is certainly a nice tool for that. Does this make sense, guys? So what's nice about this tool is that now you can take a look at, you can see a Netwox 33 spoof Ethernet packet, right? So ARP, basically, if we look at Netwag 40, right? There's another one there, 78, I think it was, that we were using. Reset every TCP packet. You see that? Do you guys remember what SYN flooding was? I can't remember. It was probably 76, huh? Yeah, SYN flood. So as you can see, we have all of these different attacks. So it's certainly worth spending a little bit of time just looking at all of the options that you have, right? And how you can, go about using it. Where was it? 76. You can see you just double click on it. And then now, instead of having to type everything, right, all the different values on the terminal, you can kind of build it here, and it's going to also build you the command line command, basically. Is this clear? All right. So this is the Netwox tool. As I said, you can use it if you wanna run the GUI interface. You just run sudo netwag. It'll open it. I've just been using the command line. So I did Netwox. And if you do like Netwox 33 -- help, it'll basically provide you all the fields that it's expecting with a brief description of it. Okay, so that is that one. There's the Netwox redirect, ICMP redirect attack. So that's 86, I think. You can see that sniff and send ICMP redirect packets. Okay. So that's another scenario you can think of. Okay, we talked about SYN flooding, which was 76. We talked about TCP resets, which is 78. So in this case, yeah, so just like we had, oh, there's a question. So somebody's asking, is there an index where we can find the different Netwox numbers? The names? Does it mean the names? Is that what we just did? So to do that, you have all these are the indexes, right? So for instance, 33, 78, 76, I think, the SYN flooding. So, okay, gets it now. All right, so yeah, so exactly. So if you want, if you want the attack, the Netwag will do it, and then it's got the index value next to it. Okay. All right. So it seems like that was clarified. All right, now, as I said, just to kind of conclude, we were talking about the reset attack. So that was just Netwox 78. And really just you need to specify the filter, the appropriate filter, which is usually, you just have to say host, think of either the source or destination, and then specify the actual IP address in question. So 192.168.1, .36 or something. Okay. We've talked about that. So Netwox 82, let's take a look at that one. Sniff and send ICMP, destination unreachable. You can see this whole family. There's a whole family here of related attacks. Okay, you can try that also for video streaming, see what happens. And then, of course, the TCP session hijacking, which will be, a more complicated. I'm not going to get into the code of that today, but that's definitely harder for sure. If you're going to do this one in Netwox, it's going to be command 40. All right, so this is going to be, just want you to know, 40. I actually, this implementation in Netwox is actually more difficult, and I've provided, it takes actually 2 types of packets that need to go out together, but I provided that information on Brightspace, so you can see that in there, because it does take a little bit of work. Well, that's why, that's one scenario where we're gonna try to do it with Python, which might make it a lot easier. Okay. All right, so that's basically, so that's the Netwox tool. I think, it doesn't require me to take that long on it, but I think it's clear enough, right? So you have a GUI interface, and then you can do the command line, and then you understand each attack can be done by an index position. So are there any questions so far? That basically should complete your resets attack homework. And so we should be ready then now to start talking about the bigger, more complex problem of TCP session hijacking. So any questions before we move on? Nope. All right, great. So what we're going to do on Thursday is, as I said, today I'm just doing the lecture, going over the ideas. On Thursday is just lab. So, I'll be here if you have questions, we can go over things again, but it won't be like new material or anything, just work on the problems. Okay. So what I'm going to do now is I'm going to switch over to kind of the whiteboard basically, or actually let's go to Brightspace actually, because I have some materials there. So let's do that. All right, so if we look here on right, if you look over here, 454. So we are basically at this module at this point. We are at the kind of the last set of attacks. And then after that, we're going to start moving into defense, basically, which, you know, will be the intrusion detection system. So as soon as we finish with this session hijacking, we should be able to do it. So you have currently 2 homework assignments, right? This one I think is probably due this Thursday, right? Oh, no. Did I assign the SYN flooding last Thursday? What did I say about it? That it was due this Thursday, correct? Oh, those are due? Really? So spoofing. Oh. The trace route and a fake 1.2.3.4. Okay, those are due this Thursday. Okay, I didn't know that. Okay, yeah. So, all right. Let me do that then. All right. So it says here you assign the spoofing labs. Do this Thursday. Soft today. All right. So then let's see. Let you guys help me out here. So if spoofing is due February 3rd, okay. So these are due February 3rd. Then SYN flooding would be due a week from Thursday, correct? Okay, all right, so let me do that one then first. New assignments, which we did a little bit of it today, actually. So yeah, you're right. So SYN flooding, I'm just gonna do as an independent problem, this one, that way it's easier for me to grade. So it'll be due on the 10th. Open now. It'll stay open until Saturday, 12. And there's a question. So when is the ASA project? I assume he means. It is a group project in theory. 2 to 3. Yes. Right, I had said this. So 2 to 3 people. It's a semester term project at the end of the semester. Okay, Andrew? Project is due at the end of the semester. It's just one big thing. One big thing. One build, you know. There is no project A or project B. There's just one project. Do you understand? I mean, because I talked about, do you guys understand about the project, right? We've talked about it. Yeah. So there's only one list of questions. Address them. In some virtual environment, a combination of packet tracer, simulation. You can use the equipment in there if you'd like, but it's not required. You can take one of the, we have some, what do you call them? Some Raspberry Pis in there. Take them home. I'm sure they'll let you. Just you know, just kind of like, don't just take it. Request to take it. But yeah, all right. So yeah, I'll change that, Andrew. If it says project A, project B, I'll change it. Okay, it's just one project. Okay, all right, great. So let's just finish this one. So this is the SYN flooding attack. Let's just say complete the SYN flooding attack as discussed in lecture, and you can view the video. View video of 2/1/2022. Okay. that's what we did today, where I demo basically try to connect using Telnet while at the same time you run a SYN flood. Okay, is that clear enough, guys? Make sense? All right, great. So that one's set. And then the TCP reset, I'm also going to do that now. So this homework is set for a week from Thursday. Now let's go to TCP reset attacks. That's what we just did today. Here's the PDF. Again, just read through the seeds. Also read these. These are just, you guys know this, but it's from your managerial book. So just take a look at it. So this assignment is, we did this today, so this can also be due a week from Thursday, correct? You can do both, SYN flooding and resets. Yep, all right, great. So I'm gonna do then homework assignment, TCP reset attacks. This is going to be due on the 10th at 10 p.m. This is, and then it'll stay open until the 12th. Okay, complete the TCP reset attacks as discussed in class. Basically, reset the following connections. So it's going to be what? It was Telnet. It was also SSH and YouTube. Let's say video streaming, which might be the harder one, but that's why I gave you Netwox so that you can play with it. So video streaming such as YouTube. Clear enough? Yeah. All right. So this is yeah. So there we have it. So today, then, in the time that we have left, so if there are no questions, I'm not seeing any questions from anyone. So in the time that we have left, we will then take a look at session hijacking attacks. This is its own topic, but this will not be due since I don't have that much time left. I'll just kind of do a brief introduction to it, and then on this Thursday, as I said, just open lab, help you out with any of those assignments due. Next Tuesday, I would continue with the session TCP session hijacking discussion, and so that homework would be assigned at that time. Does that make sense? All right, so let's think a little bit about what we want to do. So I have under TCP session hijacking attacks over here, I have some things for you to look at. There's, of course, the seed labs. Read through the description of session hijacking on it. So we can click on that one. There's another question. What? Oh, they're still seeing the VM. I'm sorry, guys. Okay. So you should now be seeing, so as I was saying, just go to the table of contents, right? And then session hijacking. Notice here that this is the last really of some of the main attacks that we're going to do this semester. We might come back to some more, but our very next topic is going to be intrusion detection system. Also, since I'm seeing this right now, keep in mind we have exam 1 coming up. We are currently on week 4, correct? This is week 4. Next week, we're doing session hijacking all week. So the following week is the exam. Okay, it'll cover up, week 6 up until then. So The exam is on week 6. We're currently on week 4. It would be on the date February 15th. Correct, guys? February 15th would be the exam during the lecture time. Okay? All right, so hopefully that's all clear. All right, so 2 weeks from today, basically. So that also, keep that in mind. And then after that, we'll start with defenses like intrusion detection. So here, under session hijacking attacks, we can take a look. We were gonna look at the PDF, and then we'll come back to other things. So let's just kind of motivate. So as you can see, this is the Seed Labs handout for TCP IP attacks. I believe I have gone as far as, that's the, sorry, I believe that's the latest one. I believe that's the most current one. As you can see, the goal of this was just to look at some attacks in particular, because this is a family that's different, right? So you probably never thought of, just like the networking attacks that exploit just the protocols and their design. So far we have covered, you guys know what, TCP from your networking courses. And then we've covered the SYN flooding, SYN cookies. We've covered reset attacks. Now what we have left is the TCP session hijacking, and we have the reverse shell attack. There's a few other things out, other labs like Mitnick attacks. We can take a look at those later. But our goal will be here, right? We're actually going to do 3 things for a session hijacking. We're gonna do, it's actually fun. We'll inject a command into a connection. So remember, the idea is you have a client server connection, right? And now our goal will be to insert a command to steal a file somehow, and also to do a reverse shell so that we can get a command line where we can type commands. Do you guys see that? So that's basically the objectives of that. This attack builds a little bit on top of the TCP reset attack. Okay, so some of what we saw today, is important for that one. As you can see here, we have so skip that. So SYN flooding, we've covered that, and that's done. And we've gone over scapy, so I think you guys should be comfortable with that. We did the TCP reset attacks today, so you can take a look here at the code that I kind of discussed. And now we are ready for TCP session hijack. So the objective of the TCP session hijacking attack is basically to hijack an existing TCP connection, an established session between 2 victims by injecting malicious contents into this session. Okay, guys? So if this connection is a Telnet session, for instance, which will be, kind of what we have to do, right? Because it'll, what's the problem with injecting something into an SSH connection? What would be the problem there? We can spoof some of the packets, but the actual command that we're sending, right? Let's say ls-l, or, what's the problem with that in an SSH connection? We don't have the key to encrypt the payload, right? So how do you actually insert that in? Do you guys see that? So, that encryption once again comes in to make things, a lot harder, right? So, but anyway, as we look at this from the point of view of Telnet, it should be pretty interesting. So if this connection is a Telnet session, attackers can inject malicious commands, deleting an important file, for instance, or just running some commands. So we'll take a look at some of the dynamics of how that works, and it should be pretty interesting. We have here a nice little diagram of kind of the idea. So first of all, you will have a client and a server, right? So you have the client, so I can do the annotation here. So we have the client, which will be the Telnet connection, or sorry, the Telnet client. So here, for instance, this would be Telnet and a client, right? And then this is the Telnet server. Okay, So then what the attacker wants to do is the attacker needs to insert packets that look like the packets of this connection. Well, we've already established in some of the things that we looked at before that we need to know certain things about the packets in that connection, right? What were they? IPs, source port, destination port, and what else? Sequence numbers. And those are the difficult ones. All right, so this assignment is a little bit tricky because of that. But once again, like we did with the reset, we're going to look at manual ways of getting it and then automated ways of getting it as well. All right, so again, at the end of the day, we're going to spoof some packets and they just have to look like the connection itself. The payload, once we figure out how to like put them in the connection, the next thing is the payload. So our payload will be just sending one command or sending also like a whole line for a reverse shell. Keep in mind, the attacker is impersonating Telnet client. So if this is A, this is B, and this is C, the attacker C is pretending to be A. So whenever C sends something to B and B replies, where does that packet go? Who does it go to? A. Do you see that? It'll go to A because usually the server will not say something like, oh, I'm going to send it to someone else. You're basically inserting packets into this communication so it doesn't suspect anything. So usually things are sent back to the client, right? So there's some limit to what you can do unless you take even, with a very simple session hijacking, there's limits to what you can do. But if you basically do open ports, etc., you might be able to get away with more, right? Like trying to get a reverse shell, for instance. All right, so that's the idea here. Okay, so let me turn off that annotate. All right, so now, as we were saying then, causing the victims. So the idea is in this connection, if this is a Telnet session, the attackers can inject malicious commands into this session, causing the victims to execute the malicious code. And then figure 3 depicts how the attack works. In this attack, you need to demonstrate how you can hijack a Telnet session between two computers. Your goal is to get the Telnet server to run a malicious command for you. And we're going to assume that they're in the same LAN. So then we're going to see that how to launch the attack here. So we will use scapy to conduct the TCP session hijack attack. And then that you can see the code here. I'll provide more information on this code next Tuesday. Okay, so we'll go over kind of like what I did today. I'll do on Thursday. Obviously, the values here are going to be critical, and we'll be using Wireshark, right? At least initially, to be able. The very first example will just be an established Telnet connection. So at that point, the traffic is just waiting there, and then you can just read those values from Wireshark. So you can use Wireshark to figure out what value you should put into each field of the spoofed TCP packets. So you can see here, we're going to need the source and destination from the IP. From TCP, we're going to need source port, destination, some flags, right? So we're going to have to think about those flags. And now notice we have both the sequence number and the ACK number. So there's going to be these numbers that we have to kind of think about. Do we need both of them? Do we only need one, depending on what we're trying to do, etc. And also notice here, now we have a payload or data, okay? And this is where, because of course, if you're doing a TCP connection, we're not just resetting the connection. Now we want to legitimately insert a command. So the simplest one, PWD, or the simplest one, ls space -l, right? So if I'm in a Telnet connection with another from here and the servers over there, I'm connected to it. I type ls, that server will actually execute that command for me, right? But now the attacker wants to be able to send that command in there. So if we go back over here, it's like we can say, if I go to annotate, the attacker wants to craft the packet, and the payload of that packet is ls-l, so that when it gets to the server will literally execute it. So let's say, for instance, another simpler one, pwd, right? So it sends the command pwd. What is pwd in Linux? It gives you the path, right, that you're currently on, the full path. So what's going to happen is when it executes in the server will issue a packet sent to client. What do you think this packet will contain? It'll contain the results of pwd. So for instance, it could have home C. Do you guys see that? But this will only be seen on the client. The attacker will never see it. You don't see it on the server. It is basically as if the client had typed pwd and now it's getting home C. Is this clear, guys? Because this is actually the first problem in your assignment for such session hijack, right? It's a tricky one to be able to get. You will need 2 VMs for this, at least, okay? So have an established TCP connection and then do the attack. Is this clear enough, guys, so far? All right, great. So I think that's good motivation for today, just to kind of give you an idea of how this this works. The idea, I will, as I said, there's a lot more detail of the mechanics of it. We will go over that on next Tuesday. And then remember, this Thursday, I'm not going to give any additional material. It'll just be a open lab. So I'll be on both Zoom and here, and then just solve your, whatever questions you have on the different labs. And then I've graded one of your assignments, I believe, and I'll be grading the next one this week. Okay. Any questions? All right. So let me stop the recording here.